Okay, welcome back to 2D Kinematics Horizontal Displacement Part 2. So in the first part of this video, which I will link below, we talked about someone running off of a cliff trying to clear 10 meters of rocks, and we wanted to know, was 5 meters per second horizontal velocity running enough to clear that 10 meters? So if you'll remember, I walked you through some equations to solve for this, and then we ran through some MATLAB code that rather than just giving you a single end value that suggested that we could clear it, we actually went through and turned this into a continuous variable so that we could actually plot these displacements over time. And then we could also plot acceleration and velocity over time. So the next thing that we did, these are some of the equations that I used. The next question, or the question that I ended that video with, was could we figure out what the minimal horizontal velocity is to clear those 10 meters. And that's what I'm going to walk you through today. We're going to do this in MATLAB. If you go back and watch the other video, you saw that I was just kind of plugging and playing, and it looked like it was around 4.1 meters per second was going to just barely clear it, but that would be the minimal amount of speed or velocity that we needed to clear 10 meters. Okay, let's hop into some code. So what I have here is the code that we ended the last video on, so please go check that out if you haven't already, because I'm going to skip through most of this stuff just to make sure that the video is a little bit quicker, because we really don't need to add too much more to this. But just to give you a brief idea of what we're going to be doing here, we will be basically running a bunch of loops while certain conditions are met, and within those loops we will be running the loop that I went through in the first video. Okay, so the first thing I always do is I clear everything. Our distance to clear is going to be the same. This is 10 meters. Right? On each iteration of our larger loop, we're going to calculate a clearance value. So this is going to initially be set to 0. So this is assuming the person just steps off the cliff with a horizontal velocity of 0 and drops straight down. They clear no distance, right? But we're going to iteratively run through, do a bunch of calculations, and on each of those iterations, we're going to get a clearance value, and this is going to progressively get larger and larger and larger, and we're going to get to the point where it's 10, and we're going to say, okay, this is our velocity where we had clearance of 10 or just over 10. The velocity that gives us that clearance is what we're looking for. And I'm going to collect those velocities in a variable called all velocities, like this. So this is going to collect those. And I'm also going to create just a variable that will collect the iterations that we run through. And so I'm going to call that variable, it's completely arbitrary, I'm going to call it j. And so I'm going to set j equal initially to 0. Okay, so what I'm going to do is I'm going to create a while loop that is basically going to look at clearance. It's going to say while clearance, the end value, which initially is 0, while the end value is less than distance to clear, which is 10, plus 0.01. So we're looking for while the clearance is less than this. Okay, I don't need that there. All right. First thing that we'll do inside of this while loop is we will count our iterations. So we're going to say j is equal to j plus 1. So the iteration is equal to the current iteration, which starts at 0. So on the first time through, this is going to be 1. It changes to 1 out here. So then on the second time through, it's 1 plus 1 is 2. On the third time through, it's 2 plus 1, so it's 3, and so on and so forth. And then the rest of this stuff I'm going to keep here. I am going to tab it in. And just so it stops giving us this, it's red like that because it's waiting for another end variable down here, or another end call, rather. And then to make sure that all of this stuff stays in line, I am going to just indent it. So we have this while loop that we created in the first video nested inside of this new while loop. Okay, so let's see, we've got everything else is basically going to stay the same. Our initial position is still 30. Our initial x position is still 0. Our initial y velocity is vertical velocity is still 0. And now what is going to change is this x velocity. So our horizontal velocity is what we were kind of plugging and playing with last time. Instead of plugging and playing, what we're going to do is the first one that we want to do is 0.01 meters per second squared, but we want to do this iteratively. So every time through the loop, we want to change this value, and we want to gradually ramp it up until that condition for clearance is met. And so what we want to do, this is why we created this iteration variable, is we want to multiply 0.01 by the iteration. So on the first iteration, our velocity is going to be 0.01, and j is going to be equal to 1. Now on the second iteration, j is going to be equal to 2. And so our velocity is going to be 2 times 0.01, which is 0.02. On the third iteration, it's 0.03. On the fourth, it's 0.04, and that's going to keep going, right? So this velocity is going to change on each iteration of this larger loop. Now, after that, nothing else is going to change, right? Within this nested loop, it's going to be calling in all the same things that we called in last time, in the last video, right? None of this other stuff is going to change. So really the only thing that we're doing is changing this velocity inside of the larger loop. All right, so hopefully you're following that so far. The other thing that we're going to do is outside of here, we are going to say clearance. So we're going to update our clearance variable, and plus 1 is going to be equal to our final position, position x, n, right? So if you remember, we go back up here, clearance was initially set to 0, and clearance is going to be updated every time. So clearance is going to end up being an array. It's a 0 here. The first time through, we run through, right? And the big thing that changes is this velocity. So the first time through, the velocity is 0.01. It calculates all of the things that we calculated in that first video, and our final position, which, if you remember when we ran 5 meters per second, was 12.3. Well, now instead of having 5 meters per second, it's 0.01 meters per second. So it's going to be much smaller. And that is going to get appended onto clearance. So clearance would then be 0, and then whatever this new value is, and then it runs through the loop again, and it appends it, and appends it, and appends it. And it's looking for the point at which that the clearance is exceeding 10, right? Or in this case, it's actually 10.01. And once it exceeds 10, once clearance exceeds 10, this while loop, the conditions no longer met, so it will stop. So that's going to end our loop as soon as clearance exceeds 10. Okay, and then just to make sure that everything's running correctly, on each iteration of this loop, I'm going to display to the user the velocity. We'll say display running. This is going to be the horizontal velocity. And that is, we called this velocity x. And we'll call the first one, although this is a number, so this isn't actually going to display, so we need to turn this number into a string, which I believe is just num string. Okay, and then we're also going to display the final clearance. So we'll say clearance, and we're going to do the same thing, num to string, and instead of velocity x, we're going to give us the clearance value that we just calculated, the clearance. That might be one too many. Okay. All right, this should all run. I just want to make sure let's just go through it really quickly one more time. Okay, so the distance to clear is 10. Initially, we set clearance to 0. And then all velocities, this is just going to, initially this is an empty array, and it's going to collect all of our velocities. J is initially equal to 0, but it updates on every iteration of this outer loop. And this outer loop runs on the condition that our clearance here is less than 10 plus 0.01, right? So as soon as it exceeds 10, we don't care anymore. We want to know what is the velocity that is at 10, right, where we get 10 as a clearance. Okay, then we run through basically the exact code that we had last time. The only difference is now we're iteratively updating velocity. So in our last video, this was just set to 5, and then we plugged and played with it at the end. Instead of plugging and playing, we're now actually iteratively running through from 0.01 meters per second in steps of 0.01 meters per second. We are iteratively running through this. Now you could change the steps at which you run through it however you want. You could do, instead of 0.01, you could do 0.1. It doesn't really matter. But here, let's do 0.01. Let's try to be pretty accurate. The rest of this code is exactly the same. And then down here, we are appending to clearance. And yeah, okay, let's go ahead and run this. It's going to ask me to save it. I'm just going to save it as temporary. Fine. Let's run it. Here we go. You see it running now, and it's running through all of these velocities. So if I drag this up, look, clearance, clearance, clearance. Somehow it's, oh, I know what it's doing. We don't need clearance 1. We just need clearance. All right, let's run that one more time. We'll clear everything. And I'll keep this up. So what it was doing before is I was calling clearance 1, which is 0, which is what we initialize it as. So let's not do that. Let's just call it clearance. Let's run it, and you're going to see it. Yeah, here we go. Oh, it's calling everything now. That's why I did that. All right, let's think about that for a second. Clearance. Oh, I know what we need to do. We just pull this in. Copy. Paste it here. Okay. Third time is a charm. Oh, you know what? I've got clear out at the beginning, so we don't need to do that. Let's at least clear this so you can see it. All right, let's run it one more time. There we go. So now on each iteration, we are getting the velocity and the clearance. So you see the velocities here and the clearance that we get. You see, so the minimum velocity that we needed to get over 10, so I've got a 10.01, so maybe I should have done 10.001. The minimum clearance that we needed to get over 10.01 was 4.6. The minimum that we needed to get over 10 was actually 4.05 meters per second. So that's pretty neat, right? You can just set this up in MATLAB. You don't need to plug and play to get all the way down to 4.05 for that clearance value. Okay, I hope you enjoyed this video. I showed you just a very simple way to do a nested loop to solve for this velocity minimization problem. This 2D kinematics are always fun to come back to, so I was I was happy to do this video. If you want to learn more, please feel free to reach out to me. If you like this video, like it, subscribe to my channel. I'm going to be uploading a lot of content like this. You can also check me out on Twitter, GitHub, LinkedIn, and ResearchGate. All right, until next time, keep coding.